Hello everyone, happy Easter and welcome to the third lesson of C# Bootcamp. This time we will try to talk about such topics as error handling, files, and debugging. So let's get to it. We will start from going through what we have done in the last lesson. And in the last lesson, we did very basic file processing. We had a recipe input, which is basically this recipe right here. And we turned units of cooking into standard system units. So cups, 1 cup would be converted into 240 milliliters. Teaspoon would be converted to 4.93 milliliters. And lastly, tablespoon would be converted to 14.79 milliliters. So we take this number and we multiply it from the equivalent multiplier of that unit. So we read this file. When we discover a unit, we check how much of that unit is there, and then we do processing. We multiply these two numbers and replace the old number with this number. So that was the logic of the last program, and the code, it was very simple. We had a basic for loop, which would go through. So we would first split this file into words, and a word is just space separated characters, essentially. So we would go through all words in this file. So 1.5 cups, all purpose, flour dot 3.5, and so on and so on. And we would, figure out, and we would then try to standardize each unit, each word, into a SI system, unit system based measurements. So everything in milliliters, basically. So we would standardize cooking unit, and that means finding, checking which word that we are checking. So getting the word that we're checking and then seeing if there is any multiplier for that word. So for this word, there's obviously no multiplier, and for this word, there's obviously multiplier, this one. So it would be returned. For this one, -1 would be returned, indicating that nothing was found. And for this one, 240 would be returned, indicating that something was found. All right, give me a short moment. Okay. Let's continue. So that was basically our solution. So we would go through every word, find the multiplier, and then replace. So find the multiplier. If it's -1, it means it's not a multiplier, it's not a unit. And if it's not -1, that means we found our unit. So we go through all, and eventually we get the numeric value of milliliters for that amount of the old unit, and we convert that to milliliters and replace whatever cooking measurement that was to milliliters. So that was the last lesson, what we did. And in this lesson, we will try to go into a slightly less convenient scenario when maybe we won't have a unit here and we'll have something broken. Maybe we'll have something like this, like a cup. How do you treat this, for example? So we'll go through different scenarios and we'll try to come up with the most appropriate solution. So the plan is this. Read ingredients from a file, recipe.txt. So that is one. Second is to validate the file, basically to check if the file can be processed in the first place, and if it cannot, we will throw an exception, an error. And third thing, that would be pretty much all actually. Debugging basically is the third thing that we will go through. So two very simple requirements. Instead of reading from a text, from hard-coded string, we'll read it from a file, and next we will validate the file if it can be, if it is a valid recipe or not. Okay, let's get to it. So the first requirement, I'll mark them 1, 2. Debugging is just side topic. So the first requirement is to read ingredients from a file. In C#, well, first, what is a file? Well, everyone, whoever is tech savvy enough to be able to watch this stream probably already knows what a file is, because that's just a fundamental part of how we work with computers. So what is a file? Would anyone like to give their own definition of what a file is? As I wait, I'll just move this recipe into the file. So there are 3 quite good answers about a file, and they are something that contains some sort of data, a container of information, in a container of data in a specific, a container of data in a specific format or type. All of those are pretty good answers. And last one, file is something you use to store some kind of data. All of those answers are good. My answer would be is that file is just a resource in your computer that holds data. It's portable. That's a very important part of a file. You can move it from one place to another, and you can send it to people. And the thing about file is that just because something ends with JPG or TXT doesn't mean that it should hold text or an image. File extensions actually have nothing to do with what a file contains or how you process a file. All a file extension does is it helps the system pick the best tool for the job to process the file by default. So, for example, if I double click a CS project file, it will, open Visual Studio. if I double click a txt file, it will use, this thing. But nothing prevents me, from opening this with Visual Studio or WordPad or any other application. So files really are just data, and how we work with those files really depends on what kind of data it contains. It has no importance of what file extension we use. It's just a nice hint for other applications to know how to read this file. In other words, it assumes that a file can be processed as a program, as a text, as an image. But if we use a different context for the same file, we'll get very different results, obviously. I cannot read a txt file as an image, and I cannot read an image as a txt file, else I'll see something that I might not want to see. So we have created a file, recipe.txt, and it stores recipe information. How do I basically turn this and delete this and convert this into something that I read from a file instead of hard coding? So in C#, if you want to read file contents, you will have to use a file class. And it's very intuitive. What do I want to do? I want to read all text. Everything. I want to read everything in a text file. Where's my text file? Well, let's say that my recipe.txt file will be at the same location where my application is. So next to my application, I will have recipe file. So I'll write recipe.txt. What do you think? Will this work or not? For now, I'll comment these out because they are not relevant. Will this work or not? Why won't this work? So everyone is saying it won't work, and it won't work, but all the reasons that you guys are saying are wrong. It won't work, but not for the reasons you say. So if I run this application, it says could not find file, but look closely where it's trying to look for the file. It's trying to look for the, let me try again. All right. It's trying to look for the file in source, repos. Like someone said, directory is not specific enough. Well, directory is very specific. It shows all the way to my basically output folder. So remember when I said bin debug .NET Core app? That's where the application is output. That's in this directory, this application is outputted. So it basically says that after I built my application, the build itself did not include the file. And as someone already noted, rightfully so, it did not copy a file. So when you're working with, just test data, playing around, make sure you click on the file that you use for data and you select copy if newer. This will basically mean that if I build this program and open that directory right here, it means that this file will end up being copied next to it. So let's do that. And I will delete this and this and this and this. And you can see recipe was copied. What? Maybe not. Let me delete and delete. Let's run again. You see, it was right. It shows date modified, not date created. And I created this file 7 minutes ago. So everything is great. Joe asked, I'm sorry, but what's the name of the extension which automatically adds the using directories? It's called VSharper. I'm sorry for not talking about this. So if you want to follow along, you will have to add a using statement using system.io, and I'll type this in the chat. Sorry, I forgot. So this one, type in the chat, add that in the files, in the using statements above the namespace. Otherwise, it will say it's not recognized. All right. Let's continue. Okay. Michael asked, will that copy with build option work with debug as well? Yes, it will. And as someone noticed, control dot will also allow you to autocomplete and request a suggestion for a not working line of code. So not a big deal. The IDE should help you out in this case. Anyways, it now works. We managed to read our recipe. So let's just print what we read from a file, and you can see what you expect to see. A proper echo, basically, of the contents of that file. Great. We can proceed. So we have this requirement done. I'll put it as plus. We are reading text from file. Actually, when you are working with files, you should be careful. Right now, we are being very simplistic. It just works. You know, we are using a very high-level method, which does a lot under the hood. And maybe not for right now for our specific use case, but for knowledge in general, it's worth understanding what's going on under the hood. So let's try to figure out what is going on. Let's make our own read-all-text method. So I will do just that right now. Static. What does read-all-text return? It returns a string, and its name is read-all-text. And we require a path, the file that we read. For now, I return an empty string so that the method does not complain simply. Now I will try to implement what's going on. So when you think about a file, someone already mentioned that it's really just zeros and ones, a binary, something like this. But file processing, you know, we do something to make it slightly more easier. Maybe not the most memory efficient thing, but very performance efficient thing. To make working with files easier, because a file usually has data, and data, you know, usually refers to numbers or text. We can process that data easier if we have some groupings. binary is not something we can understand very easily, but if we convert this into something that humans can understand easier, like text characters per se, we can process the file easier as well. So basically, if I split this, what I wrote here, into groups of 4, uh, 0, 0, 1, 0, 1, 0, 0, 1, for example. I basically get, sorry, not groups of 4, but groups of 8. Groups of 8, I basically get something called a byte. This is a byte. 8 bits make a byte. Why 8 bits? Because if I type Alt 64, I get ant. If I type Alt 255, I get another symbol. Alt 251, I get another symbol. Basically, if I type Alt 1, I get a smiley, and so on and so forth. Basically, a byte is fundamentally how we can write a simple character. And it's very convenient to put data into that format. So when we talk about raw data, we actually mean bytes, many bytes, bytes array. And the thing that allows us to work with bytes is a stream. So stream is something that has bytes under the hood, and it processes them in some way, either writes or reads. Naga asked, how do I get the text file to save in the default directory? Missed that part. Right-click on the file, hit Properties, and select here Copy to Output Directory, and select Copy if newer. Yeah. Thank you, Zach, for clarifying as well. So this is a byte. 8 bits is a byte. Bytes array is a stream, basically. So that's the information you need. 8 bits is a byte. Bytes array makes up a stream. With that information, knowing that essentially when you work with data in its raw format, you're working with streams of bytes. Knowing that information, we can now start going deep into file processing from its very core. So in order to process a file, to read its content, I need some sort of a stream. So I'll try to create a new stream. And there's a lot here. There is even a file stream, as you can see. So file itself is a kind of stream. Let's write that. But it has some scary stuff that I wouldn't, like to deal with, though it has simple stuff as well, like this path. And in what mode do I create this stream? I create this stream in open mode. And again, I pass the path. So I create a stream so that I can read contents of that file. Then I say stream read you see a read method, like a single read method, it says reads a sequence of bytes from the current stream and advances the position within the file stream by the number of bytes read. So it basically takes bytes array and loads the elements in that bytes array based on how many elements I read from the stream. But there's an easier way to do that, and I marked it in a wiki. To be honest, I don't remember by heart how you do that, but I will soon, because it's definitely not something that I do on a daily basis. Stream. Right. Stream writer. So it's slightly different. Stream writer, stream reader, this one is. Implements a text reader that reads characters from a byte stream and a particular encoding. Okay. And, whoops. True. Probably not needed. Okay. Yes, good. So this is stream reader. This is actually what we'll be using this. So why would you ever want to use something like this if it complicates things so much? Well, what do I have with a file? What can I do with a file class? In terms of reading, I can read either all text, all bytes, all lines, but I cannot choose to read up to a certain point, and I cannot really read in a very optimal point. For example, imagine if you wanted to do a multi-threaded application which reads the same file from multiple processes. I wouldn't be able to do that. So when you want very advanced and optimal solutions, when you understand what you're doing with a file, use streams. Don't use a file class. In this scenario, I'm just gonna do the equivalent of what a file does, or what this method does, because we are not going to go into the depths of it. We're not going to make something very optimal or very great. We're just gonna make a basic scenario in a different way. But when you do have very specific requirements and very specific way of reading a file, you can do whatever you want if you use a stream. You cannot do whatever you want if you use a file. Stream is just a lower level thing which has more options to interact. So what options do I have? So you can see I can I can peek, I can read asynchronously, I can read a block, I can read till end. And reading till end basically means read all characters from the end of the stream. And that is my result, basically. So this is how you would read file contents from using a stream, equivalent to this. So I deleted that file because now this is my method. I'm not using File.ReadAllText. I'm using my method, reading all text. Let's try to run this. Perfect, it works. Let's try to run this again. Works. For now, that's good. And the second thing would be, how do you write to a file? Our requirements, I'll move them a little bit up. Our requirements here suggests that we need to output converted recipe to a new file. So basically, output standardized recipe to a new file. And just like I had File.ReadAllText, there is also File.WriteAllText. Let's do that. File.WriteAllText. And I pass the path. Where do I want to write? I want to write also to the same place, but I will call this recipe converted.txt. And now I need to say, what do I write to that file? I write standardized recipe. One thing to note is that the first argument is a path, and the second argument is the contents of that file that you're writing to. Don't mix it. And as a rule of thumb, you should think, like, how to remember which one is first. Try to, think which is more important. Is the file name more important than the contents? And in this case, yes, it is, because without the right path, you wouldn't be able to write this. So this one is more important than this one. That's at least my way of seeing it. That's why it's first. Path goes before contents. Remember that. So this will create a new file and will write the converted recipe as the contents of that file. If I hit Ctrl F5, it says input string was not in correct format. That's probably because line 21, line 42, line 56. That's because I think we are parsing numbers without sanitizing them, without trimming them. Because a number, if I open a recipe, it didn't do that in this scenario, but maybe it did. Basically, a number could have an end of line symbol and therefore be bad. If I call trim, I basically make sure that a number will not have incorrect symbols. Incorrect, I mean empty spaces or end of line symbols. So if I run again, it is still the same problem. Let's do a console write line and print the amount text. This one, to be precise. So powder and dot, and then 1. And it says 1 was not in a correct format. When I try to parse 1, it says it wasn't in correct format. Let's print it slightly differently. I am doing string interpolation here, remember? And just adding quotes so that I see if it has any spaces. Interesting, you see it was split this way. So powder dot 1 for some reason is considered as one word. Right, I think I understand now. So what bug did we just introduce, guys? Do you see? Does anyone see what bug we just introduced? This is a problem. Exactly, end of line character. So we not only need to split by an empty space, but by also end-of-line characters. So we need to adjust the logic that does the split. So here, the separator will actually have more than one separator. So we can pass multiple of those. So one separator is an empty space, and another one is an end-of-line symbol. So if I run now, it seems to be good. I can now remove the statement that prints it because it doesn't matter. We just fixed the problem. Again, what did I do? I just said that now I not only split by an empty line, but by also by the end of line symbol. Great. Why is that converted recipe not appearing here? The answer is we're not storing the converted recipe here. And actually, this recipe that is being read is not exactly this one. It's a copy. So next to this copy, there is this converted recipe. Therefore, if I open the output window where the program built, I can see recipe converted.txt. And if I open it, here I can see everything properly converted. So 360 milliliters all-purpose flour, 17.255 milliliter baking powder, 4.93 milliliter salt, 14.79 milliliter white sugar, 300 milliliter milk, and 44.37 milliliter butter melted. Perfect. That's the output we want. So great. That's how you would do it with a file class. How would you do it without one? How would you do it yourself? So I'll copy paste this method because it's going to be a very similar one. And again, I will make WriteAllText method. And no need to comment anymore. And instead of stream reader, I'll now have stream writer. And I don't need any contents, nor do I need to return anything. All I need is to take that stream and write to it. Write to it. But it's not quite that yet. Stream writer. Right. I can use. It has an overload that takes text literally. It should have that. Yeah. Oh, right. It has many overloads. I didn't look through all. So it takes char array, it takes every primitive, it takes an object. There are many overloads that it has. And of course, it takes a string as well. Great. So if I say string contents, or rather text, I can do that. So write all text. That's how you would do it manually, basically. So I can take this and have it like this. If I run the application now, do you think it will work? And of course, the answer is no, it won't. Because I'm asking you that question, that means it's not gonna work. It actually did, okay. Fuck. Huh. It shouldn't have. Oh, okay, it should have. Everything is great. Right. So let's say I would like to, here I have the standardized recipe written to a file. If I open that file, here, you'll see it. Oh, it's empty. That's also interesting. Great, it's empty, perfect. Why is this empty? If I write something in this file, like this, and then suddenly close it, like this, and open it again, the file is going to be empty. So what do you think is missing? I wrote to the file, but I did not really close it properly after I wrote it. So we didn't really, properly handle this thing. After we are done writing, we need to close after ourselves. So I need to call Dispose method. Dispose cleans basically up. If I hover over, it says releases all resources used by the text writer object. So it closes the file. And if I run this now and open the file, everything is here. Perfect. So let's talk about this a bit more, and please let me know if you think there is one more dispose needed. First, why do we need a dispose? Dispose is needed for when our program, the environment, the runtime is not able to manage to handle all the resources itself. It's outside the scope of the in-memory stuff that's our application running on. And something external as a file, our application has no idea what's there, how it works. Like, it cannot just magically manage those resources, Such resources like a file, like a database, like a connection, they are called unmanaged resources. So stream is an unmanaged resource. It means it needs to be cleaned up manually. And how do we clean up manually? We clean up manually by calling a dispose method. That's what we need to do, to call a dispose method to clean unmanaged resources. As a rule of thumb, if you are using an object, a class, and that class has a dispose method, right after you're done using this object, like as soon as this has served its purpose, you should, as soon as you're done, call the dispose method. That's essential. And exactly, I asked which other place needs dispose. The same for this one. Of course, reader needs a dispose as well. So not contents. Contents are just a string. So it's something in memory. Stream also, this stream reader needs to be disposed. There is a convenient way how disposing can happen, and that is done through a using statement. So instead of manually calling dispose, I can wrap this in a using statement. And this is basically equivalent. When I wrap something that I initialize in a using statement, basically here at the end of it, it will call dispose. So using statement is the same as calling dispose at the end of it. So this using new blah 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 and closing is equivalent to this new and dispose. And my computer, my IDE suggested me that this can be simplified, and since C#8 you can just write using var blah blah blah, and basically at the end of this method right here it will call dispose automatically. But for a beginner, I would probably recommend just doing this, because this is more clear than the other one. So this will dispose unmanaged resources. Stream reader and stream writer are unmanaged resources because they mess with a file. After we mess with a file, we need to clean up. So there is that. And why didn't we notice anything weird with this one? Well, if we wrote to this file in this path, for example, to the same file that we read, we would write to, it will be messed up and it wouldn't work immediately. It would just say that it's being locked, and we can try that. Here's what happens if I do this without a dispose. Let's say just this. What happens? Stream turned, for example, let's call this as well 1. Okay, great. Let's try it. See what happens. It says the process cannot access the file because it is being used by another process. Basically, this stream opens the file and doesn't close it, and this stream also opens the file, but it cannot open the file because this one is already using it, so it's breaking. Great. Now we know how writing and reading from a file works. At least in a nutshell, it's all about bytes arrays and streams. Let's move forward. The last thing that we should be doing is validating the file. How do we validate that our file should, that it's a valid file? What is a sign that something is a valid file? And the answer is, if I inspect the recipe, we have a bunch of words. So if I have a unit and something before that unit is not a number, if I cannot convert this thing before a unit, let's say it's XX, and I cannot convert XX to a number, then that means it's not a valid recipe as well. So let's write code which detects that. Right. So now we will use a proper parsing for input, for text. We always used a parse, but now we'll use TryParse. So the difference between a parse and a TryParse is that a parse returns the value, and it will error horribly if it's not a number. But a TryParse is behaving slightly differently. We take input, text, same thing again, but the thing that we return is actually a bool variable. So we return whether that thing that we were trying to parse was a number. And the output itself is a second thing that this function returns. So number style, allow decimal point, provider. I don't know what I'm doing, by the way, just a disclaimer. It's rare that I would mix those two, but now we're doing it, so let's see what happens. Right, I'm undoing it a bit. Culture invariant, culture, boom. Just trying to make it work like we did it before. So number style, allow decimal point, culture, and then the third argument is the actual result, out number, or rather amount, just amount. That's the double. So awful writing. And let's make it a bit more readable because I cannot fit it in one screen. So we take this amount text, we say that it can have a decimal point, it's okay. We parse it as culture invariant, which basically allows a dot instead of a comma. And we also say that this is the actual result. So the key parts here is that TryParse returns whether it's a number or not, and the actual result is here. Amount is the last argument of TryParse, and we get it using the out keyword. Use out keyword when you want to get a second return value from a function. And it is always used in a TryParse pattern. And what is a TryParse pattern? TryParse always returns bool whether the thing can be parsed, and throughout argument we get the actual value, parsed value. That's basically it. So we have this, and that, and all that we need now is amount milliliter. So amount milliliter is is here. We take the amount and multiply from the multiplier. That's what we had before, and we are now back in action. Let's run to see if this works. It's not broken. Let's see if the recipe looks fine. It looks just what we had before, so it's working. But we didn't really do any validation yet. We just parsed a number. Now we need to see if it was actually parsed. And if it wasn't parsed, that's an error. So first, let's go a little bit back and comment this out. And just go back to the amount part where we parsed it using a parse method. Let's run it again just to prove that it works. I opened this and it's still fine. Great. But now here comes the key part. Let me mess the recipe up. Instead of 1.5, this will be KK. And instead of 1 here, it will be X. Save. Let's run. And now we have an error. And obviously, we cannot parse KK to a number nor X to a number. We expect that the thing before a cooking unit will be a number, and it isn't a number. If we go back to code, that's exactly why we implemented that part. So again, let's remove this and let's add this back. So this one allows us to perform validation and not to completely crash our application if the number that is being parsed is not actually a number. So this allows us to add validation. So if I say if is not a number, I shouldn't let it succeed. Let me go back a bit once again to what we had before. So this line of code can cause an error. And every language gives some sort of mechanism to handle errors. C# has that mechanism too, obviously. In most languages, that mechanism is called a try-catch block. In JavaScript, in Java, and in C#, that try-catch block is actually very similar. So let's do it. Try. And the thing I put under these curly braces is a thing that can fail. A thing that can fail. So I try to do a thing that can fail. And if it failed, catch the error that caused it to fail. Exception is an error. And if I catch the error, just like any other variable, I can work with it. It gives me information about what went wrong. So, what went wrong? I will simply say exception message. And the thing I will do, remember, we can skip an iteration of loop. If it was an exception, I skip that unit that failed. We cannot do anything with it. It just failed. So we'll have to skip. So instead of skipping, of course, it'll just be return. Great. Let's continue. If I run this code now, the application will not fail because this is called error handling. It means that we handled an error. So it's not very, nice what this error said. Input was not in the correct format. Input was not in correct format. So what? Why should we care? What does that even mean? Instead, it would be nicer if we said what input was not in the correct, format. So input, this was our input. So KK, 3.5, X, and 1.25. For some reason, these other guys started giving errors as well, and I don't know why. But it could be just bugs out of trying to handle something. Again, we shouldn't always try to handle things that are supposed to fail. Actually, what are our requirements? It says validate the file. If it fails, if it's invalid, next to a cooking unit, there is no number. Throw error. Remember this, and this is very important. Just because your application crashed doesn't mean that it's the worst thing in the world. The worst thing in the world is actually if the application is allowed to run in an invalid state. That is the worst thing that can happen. And that is the source of so many problems these days too. And we should definitely don't allow that to happen. So let's delete this because that's not how you would handle this error. That's not what we, strive for. What we strive for is to have our own proper custom validation. So here we have a parse that also returns whether it's a number or not. And if it isn't a number, we will throw an exception saying that the amount text that we were trying to parse is not a number. And now if we run this application, you will see an exception. Properly so, it says KK is not a number. Great. It works. It's based on the requirements that we had. We parse a number, and if it's not, we parse a recipe, and if it cannot be parsed, we return a reason, an error, why it wasn't parsable. Lastly, let's create a new class, because best practice is to actually have custom exceptions. So I'll call it invalid recipe exception. And I'll say, so when you're creating custom exceptions, you need to write this. I won't say what this means yet because it's just confusing. It just says invalid recipe exception is an exception. So then I type invalid recipe exception. So we take a reason. Why was our recipe invalid? And we say that we will pass that reason just like a normal exception would pass that reason. Don't think too much about this yet. Soon this will make a lot of sense to you in the future lessons. Maybe 2 lessons from here. I will repeat the throw part soon. I'm sorry. I'm going back. So what did we write here? If it's not a number, throw a new exception. Throw means raise an error, crash the application, basically. Don't allow to continue unless it gets handled. So throw will throw this exception on your screen and it will try to crash the application because it's not supposed to continue working. Throw will break the application. So basically the parse statement, this one that we had before without the try part, that's what it does under the hood. It throws an exception if parse is not successful. So if I run this now, you see the same thing. Throw new exception. That's the throw new exception part. And again, we said we made our own exception just now. So let's throw it. Our own exception. And our own exception is called invalid recipe exception. If I throw it now, it's almost the same, but it reads slightly better. It says unhandled exception, recipe app invalid recipe exception. KK is not a number. Great. That's a recipe exception. That's our own exception. And this allows us to even handle custom exceptions. Soon you'll see how. But first, the questions. Zach said, isn't this scenario where you don't want to throw an exception? Basically, bad input is expected and is not exceptional circumstances. It depends, really. What do you want to do with an invalid recipe? I expect a valid recipe to be converted. I cannot do anything to fix the recipe myself. I cannot just get it. I could, write to a user, that such an exception, that the recipe is invalid and please write the recipe again. But that's not what my application is doing. Maybe my application is just reading bulks of recipes. And if it discovers an invalid recipe, it shouldn't continue. That recipe has to be fixed. Otherwise, the whole thing won't make sense. I cannot risk the whole application to be affected just because there is that invalid recipe. That's why in some cases it might make sense to throw when input is invalid. I definitely agree that there are cases when you shouldn't do this. After all, exceptions are for exceptional cases. But in this case, we are supposed to be taking recipes from a cooking website. So of course, we assume that all recipes will be valid. And if they aren't, that's a problem. And we indicate that problem by throwing a custom exception. Joe asked, what is the difference between exception and argument exception? Well, if I type, exception here, for example, we can read what it says. Represents errors that occur during application execution. And if I type argument exception, it says exception that is thrown when one of the arguments provided to a method is not valid. So if something was wrong with this argument, I could throw that exception, argument exception. For example, if I provide an empty reason, I could throw argument exception. And I could say this, I could say null or empty reason argument. So argument exception is more appropriate than just an exception because it refers to the reason why the problem happened. The more specific the exception is, the better it is because it gives us more insight on what caused the problem. And therefore, it's best if you create custom exceptions like our invalid recipe exception because it gives the absolute most insight on what went wrong. Again, that's what I would do because I know, the reason why this was wrong. But if I wanted, to handle those problems, to ignore them, I could try doing this and catching that specific invalid recipe exception and just skipping stuff. First, printing the exception reason and saying skipping word because, and then giving it a reason. Again, we already know this. I'm trying code that might fail, and I'm catching an exception, but this time not any exception, but a very specific exception, invalid recipe exception. And if this code fails, I write to console a reason why it failed, and I skip a loop iteration. I don't really need to skip a loop iteration because it already is at the end. So let's try this code now. So this seems to be exactly what we want, Again, this could be requirements. Our requirements are poorly defined. It's actually, if it's invalid, throw error. That's what we do. But we also skip the word. If we cannot convert it, we just skip it, But this approach seems to be all right, I think. It doesn't allow invalid input to be guessed, and we just ignore it. And at the same time, it shows all the quote-unquote warnings that happened, the potential issues, problems during the processing. So if we open this recipe now, I have a feeling I'm opening the wrong one every time. Because it shouldn't. KK cups. I'm not doing right. Something is wrong. Let's try again. Okay, let's see. Refresh. Nice, nothing happened. That means I'm not properly writing this text. The recipe, the recipe, I'm supposed to be writing this text to this path, but it's not working. Why is it not working? I'm trying to think. I don't know. Panicking. standardized, and then we write text of standardized in there. Oh, right, I changed this. Yeah, exactly, I changed this. Thank you. I changed this before as I demonstrated. Yes, good point. Thank you. Yes, so as you can see, those two amounts are ignored. KK and X are ignored. Yeah, so maybe this is a requirement. Let's make this a requirement. Validate the file if it's invalid. Next to a cooking unit, there is no number. Throw an error. But handle that error by skipping the invalid unit number. Not a number. Okay, great. And that's all. So let's pause here and let's continue with Kahoot. Kahoot pin is this. Nice, everyone who's watching joined. We can start. Maybe not everyone, 15 viewers only joined, but whatever. Good luck. For now, just preparation, so you still have some time to join. Again, sorry for those who are first time in Kahoot. This is the link that you should be using to join the game. And I'll lower the sound. It's too loud. Just the warm-up questions. This question, no points, as we wait for others. So in C#, I'll just give you a hint, which I shouldn't be doing. There's also File.ReadAll. I'm just giving you this hint, that's all. And yes, please move camera, I'm sorry. Always. Mysterial Nos, the lesson started 1 hour ago, and there was an announcement saying that we actually, you know, have the timing 1 hour before compared to the last time it happened, just because it is a clock change. That's why. It was a big confusion for that reason. Sorry. So about that one, didn't talk much, but there are two methods basically. So one is File.ReadAllText, and another one is ReadAllLines. So ReadAllText returns what is read in a string, and ReadAllLines returns what is read in a string array. Don't mix those two. It's okay if you don't know. It's no biggie. Pick the odd one out. Remember when I talked about what is what? Now is basically checking if you remember what I said about the 3. What is raw data and how that is related to 3 out of 4 things here. Also, Mysterial, I hope it's not a problem. You can, always watch the recording. There will be consultation anyways. And there is everything in the wiki as well. So shouldn't be a biggie. So string is the odd one out. String array is the highest level cheat folder. Cheat. I should show. It's just cheat sheet about something very, very good to know. And I'm basically putting there cheat sheets for things that are difficult to remember, but definitely useful to remember. Anyways, file is essentially a stream of bytes. So a stream is bytes array. File is a stream, essentially, is a kind of stream. And string is just something unrelated completely. The string array is unrelated completely because it has nothing to do with data in itself by itself. Like a string array could mean it's like a content of thousands of files, for example, or of one file. It doesn't mean anything. But file, stream, and byte array, they are referring to the same thing. All right. Anyways, I do let you cheat. You can always Google. Think, guys. You can always Google. So what happens when you call File.ReadAllText on a file which does not exist? Think before you answer. Because this is not a tricky one. It just requires your thinking. We had this problem at the start of the lesson. Well done. So it's file not found exception. Literally what the problem is, the exception represents. And you don't almost need to know the context. Obviously, you get the context where the file was being looked at. But the problem itself is clear just from an exception name. That's the power of custom exceptions. Which statement about an exception is false? Be very careful which one you pick in this one, because there are tiny differences here which matter a lot. The devil is in the details. False statement. False statement. And again, there's one thing that I didn't show, and I'm sorry about that. But there is another thing that's also wrong. So it's 50-50 at worst case scenario. Yes. It is possible to store an exception. I'm very sorry that I didn't show that, so bear with me as I show you what I mean. I can create an exception here. So basically, when I throw an exception, or when I use this base exception, I can always pass an inner exception inside of this. But this is no biggie, and it's okay if you got that wrong. I understand why you could get that wrong, but this one is completely wrong. A new keyword doesn't throw an exception, it just creates one. In order to throw an exception, you need a throw keyword. You can do throw new exception, but here's the thing. I can also do this. And then throwing is actually doing it like this. So just because I created an exception doesn't mean I throw it. I throw the exception with a throw keyword. So that's what I meant. It was not an easy question, I agree. But new has nothing to do with throwing. It just creates one, but it doesn't throw. Which statement is not exception best practice? Again, I mentioned. Yes, Michael, new keyword instantiates an object. In our case, new was for a new exception, and throw was throwing that exception as an error, raising an error. Yes, not all exceptions should be handled. Sometimes it's better to allow an application to fail rather than leaving it in a state which might be invalid. And about the other things, yes, we should be throwing custom exceptions because they give more details. We should prefer the program to fail early because it prevents invalid state. It's basically the opposite of this one. And we should add context to an error, to an exception if we can, because again, that gives us more ways of handling it, or at least understanding what went wrong. Special kind. Type the answer. What contains, and again, I didn't talk about this, I forgot to mention it, but when something fails, you can wait for a hint. When something fails, you have something like this, which shows the trace of where it failed. And if I explore what an exception has, you will see that it actually has this thing, which stores the place that caused the fault. And it's really nice to see, you know, wrong answers and right answers. So stack trace is the right answer. Stack trace is the thing that contains the place that caused the application to fail. Whoa, come back. I'm sorry, guys, for this one. Really sorry. Forgot to mention. What will be the output of this code? But again, this is not competition. This is learning. This is a part of learning. Something that I haven't mentioned during the lesson is mentioned here as well, which is as useful and a little bit frustrating. But I mean, you're getting this stuff for free, so pay with it with your a little bit of frustration. This was in the wiki though, so anyways, in this one you can catch specific exceptions and you can catch multiple exceptions at the same time, but handle only the first one you bump into. So what's wrong? What will this print? And surprisingly, array was undefined was the first one that people chose. But this is not null reference exception. You have an empty... Well, actually, this code will not compile in the first place because a 0 is missing here. But given there was a 0 here, which I wanted to, right? But I didn't. It should say empty array. Yeah. Tiny mistake. A 0 is missing there. But null reference exception is impossible because this one... I'll give you extra points. You're all winners today, okay? So this one is not possible. This one is not possible. No reference exception is not possible because the array is initialized, even though poorly. And index out of bounds exception, you probably cannot tell. So I would understand those who pick this one. But I mean, picking this or this one is definitely impossible. So I cannot justify it in any way. So this one is only the only one justified, and this one too. No, 4 people got it right. It should be blue, lol. It wouldn't be blue, it would be just compilation error. Okay, let's continue. I'm sorry. Double points, comeback time. Where and what file will be created? Fuck, again, I didn't mention this, so hear me out before we continue. I have 30 seconds to explain. So this is a verbatim string, and it allows basically to write backslash. This means we are at current directory. This means that we are at the root of the disk. And this means that we are at the same place, for example, at this folder. We're trying to get to this folder. So this one is very different from the other two. I explained in 30 seconds. Let's see if you understood. Okay, fair enough, fair enough. It's a difficult question, actually. It's probably not enough time for 1 minute thinking. So there are two trick parts here. First one, all of the explanations that I give is actually meaningless. Because the first argument is a path. So the first argument is the path, the file name where it will be stored. So it will be stored in this folder, and the name will be this one. Sorry, yeah, that's how it would be. So this is not the file name itself. This is not the path. This is the path. This is the contents. Really? You're missing questions? That's odd. I thought 1 minute was enough. You can give feedback about that, we'll see. If we don't handle this block of code further, what will happen? Will the application crash? You shouldn't be looking at the stream itself. You should be looking at the browser. That should be accurate in terms of, that shouldn't be delay. I mean, what happens is you throw an exception, you catch that exception and ignore it, but finally something that happens all the time regardless. I didn't talk about this in the lesson. Once again, I'm sorry. And this is because I'm mixing Kahoot in the middle of a lesson, so I might be missing out a few things. Oh, you have one screen. You could have a split screen where one side is chat, because it's literally like just a column, and another side is Kahoot. That could work. Also, you can use mobile phone. It works on mobile phone. Just get the Kahoot app. Oh, right, you don't see the questions. All right. We will come back to this soon about those failed questions. Which does not suit the others? And I just explained the situation like 3 questions ago or 2 questions ago. But we will go through this once again, right after Kahoot. This one is the odd one out, because let me show you what happens when you type any of those. So let's go in C# now. Before we really reveal the winners, let's talk about the things that people failed. Stack trace already showed. Here, finally, is something that always happens, regardless of success or fail. So if I do this, it always happens in every iteration. You see, always happens, always happens. If I skip the word, it still happens. So every single iteration, it always happens. That's finally block, always happens. Even if you are, returning here, like you think you're just stopping the application, it still always happens. This is not the last line. No, this is the last line. So if I do this, it will hit still twice. So always happens. That's what always happens means. Even if you return from an application, it still hits this thing. Always happens once again. Right. So that's finally. And the last one is this one. What does it mean to write in here or, sorry, in here or in here, like this? So this is a verbatim string. String marked with @ is a verbatim string. Basically, it turns off special characters. So a special character is a backslash. I can turn off special characters with a backslash as well. So a backslash turns off special character. A double backslash means that my backslash is just a character. However, if I just write one backslash, that means my R is like being cut from being a special character, but it's not a special character, so it complains. It complains saying unrecognized escape sequence. But this is a proper escape sequence because double slash escapes the other slash. And for this one, when I have @ I can have those understood as just raw text. So that backslash will just work. So when you have paths, always use verbatim string, because instead of double slash, all you have to do is a single slash. Much better. And so this works. It says this recipe text file exists at the root of where it is, and it is directly under the root. This dot is a symbol for root, this folder. Dot means this folder. So this and this are the same because this is a verbatim string and it cuts the single slash off. This and this are also the same because this marks it as a root and this implies it's at the root. So these two are the same other than the name, but they will be saved in the same folder. So I'll mention backslash is used to turn off special characters. Great. And single backslash at the start of a file refers to file name. refers to root disk directory. So if I write this instead of dot backslash, it will complain. You see, it says cannot find a file at C. That's where this program is being run from. So if I put slash, backslash, it reads from the root. If I put dot backslash, it roots from the current directory, and thus it works. Lastly, if I put double like this, 2 dots, it means I go 1 folder back. So current directory, previous directory, backslash. Okay. So this is current directory and this is previous directory. What does it mean, previous directory? It means that it will look for stuff at the debug folder, not .NET Core app folder, but the debug folder. So it's not finding anything there. There's nothing there, so it's failing. So be careful how you write your punctuation. Anyways, this is a relative file path. And absolute file path, yeah, previous directory, directory above. And file absolute path, full path to file from current directory where the app is running. That's basically the distinction between the two. All right. Seems to be okay. Last thing that I wanted to show today is just messing around a bit with the program state. How we run the program and explore everything that happens in it. So what I'm about to show you is called debugging. And debugging is basically an act of seeing how your program runs line by line, and at the same time having a look at every single variable and its value in the program as it runs. First, in order to be able to debug, you need to put a breakpoint. So this big red dot right here is a breakpoint. And here I add the breakpoint at the first functional line of my program, for example here. And if I run my program, nothing will really happen because I'm still simply running it. In order to debug my program, I need to run it in debug mode. So if I run with Ctrl F5, I'm just running it. But if I'm running with this, when debug is selected, or pressing F5, like I did right now, my program enters a debug mode. And in this mode, I can see everything that is going on. Let's click on the Autos window. And let's see how everything changes. So I'll take you through a journey of this program through 3 different windows. First, the Autos window. Here you can see. In the Autos window, we see that we have no arguments here. If you hover your mouse over anything, that can have a value, you will be able to explore it. So my application took no arguments. I see that I'm about to read text. Text is null for now. And then if I press this button right here, step over, or F10, I will go to the next line of my application. So let's press this button, F10, or this one. And see how things are changing. Suddenly, I no longer see args, but now I see ingredients and standardized. It actually also shows what this function returned. And it returned the same thing it stored in here. That's quite nice. I can even inspect this text in more detail, and it actually makes it nice to read as it wraps. I can select it not to wrap. So read the text as is or wrap it to make my life easier reading it. But I can basically inspect a large string and read it if I want. So if I go again, pressing F10, see what happens. Nothing really happened. If I press F10 again, see what happens. Well, standardized thingy just changed, which is great. I'm thinking also, why did ingredients change and not just standardized? That I don't understand. But we'll see. Anyways, if I hit F10, you see suddenly everything disappeared and I have only standardized left. So what conclusion could you make? What does Auto's window show? Does anyone see a pattern here? I'll start the program from the beginning. Actually, the beginning, the first line I can put breakpoint is here. So let's go through it again. First, I see args. If I go one line down, I see ingredients as well. If I go one line down, I no longer see args, but I see what this method returned, and I see ingredients and standardized as well. If I go one line down, I no longer see what this one returned, but I now see what this returned and standardized. And if I go one forward, it just shows standardized. Joe said it shows every value that has been stored or changed. Not quite. It doesn't do that. Basically, it shows the value that is at this line and at the line before. It shows everything that is currently and just before. Currently and just before. So just before I have arguments, and currently I have this thing. And to be precise, ingredients at the moment are undefined. So just before this line, I read the ingredients, and currently I have standardized. Just before I read all text, and I store that to ingredients. So that's what it does. It shows these two lines always, the current line and the line before. If I go one forward, it shows the current line and the line before. So it shows the value of this, what this returned, and what I'm writing here. If I move again, it just shows the current line, which is nothing, and the previous one, which is just standardized. So that's what Odos does. If I run this again, let's go through a prism of locals. So you see my locals, I see a lot more already. I see 3 variables. I see args, I see ingredients, and I see standardized. So what does local show? Let's go through it again. What does local show? It shows local function variables. That's correct. That's locals. And if I click watch, can I clear? Clear all. Great. Yeah, it shows values in scope. But to be precise, in function scope. Not in any scope, but in function scope. All right, let's continue. Last window, watch. I'm going through and nothing is showing. Why do you think nothing is showing up? Would you like to guess? Nothing is showing in the watch. What do I need to do? Exactly, I am not watching anything. In order for watch to work, I need to add elements to it. So let's add ingredients to the watch. And here we have it. We can see the ingredients. The key difference or the key usefulness of a watch is that you can actually script stuff in it. For example, if I'm curious, what's the length of the ingredients file? How many symbols are there? I can do that, and quite easily. If for some reason I want to change the state of my ingredients, making them valid, for example, I can do that once again. I can do all I want in a watch with a few clicks. So if I double click on a value, I can change it to whatever I want. And I can also have mathematical expressions or other code. Right now, it's not greatly useful. But when we talk about web APIs or more complex things, you'll see how valuable this can be. So this gives us a lot of freedom and a lot of power in how we can inspect the state of a running program, not just program statically here in code, but something that's actually running and stores stuff in memory. Great. Let's do more complex stuff. Let's run this program once again, and let's see what happens. So I'm pressing F10, and that's great. Pressing F10 again, and that's great. But now, instead of pressing F10, I'll press F11. And this is called stepping into. I can step into this function's first line. And every time I press F11, if that function is mine, or rather, if I have a debugging file of that function, I will be able to step into it. So I'm stepping into every function I can. Every function I can. And I can go infinitely so. And debugging code like this might be really confusing. I mean, I am basically 4 levels deep into my application. Where the hell am I? How do I know where in my application how did I get to this place? What was the path? So the best way to see how I got to where I am is through a call stack window. Stack is just like a bunch of cards put one on top of each other. You can stack things on top of one each other. And call stacks is literally what it means. You're stacking calls. So how did I call my function to end up where I am? And in this window, if you click this tab called call stack, you will see the path. Basically, the top element is, the thing that I am, because when I add elements, I add it on top of the stack. So always the thing on top is where I am right now. And the bottom one is basically the place where I came from. So if I'm stacking stuff, I can basically unstack it and backtrack where I came from. So if I double click on one element below, I can see where this function was called from. So in order to end up in find multiplier method, I called it from standardized cooking method. And standardized cooking unit method was called from a standardized recipe method. And standardized recipe method was called from line 26 in the main method. See how much precision I can tell about the flow of my application? I don't need to be a genius or super smart to tell what happened. I can simply look at call stack and backtrack. Simple, right? And when I double click on things, it even shows where in the stack am I looking. So I'm here now, and let's say this loop sucks. I hate it and I want to skip it. And you can do that with this button. It basically lets you escape the scope you are at. So if I press this button or Shift F11, it gets me out, not from a scope, but from the function. It steps out from that function. So it steps out this function, it steps out from that function if I want it. And it steps out, and if I step out again, I'll just terminate the application. So I just step over. Step over, done. Great. Perfect. So that's how you can inspect the state of your program. One last thing. If you are working on a console application, it's actually even possible to do three more things with your code. You can edit your code as your application is running, actually. Any code you can edit like that, as long as your application is absolutely paused. It has to be truly paused. There's nothing that's interacting with this console application. It's just that, the application. So my application is paused, and I can actually edit code as it's paused. If it's paused, I can do that. So, instead of writing to a console, I can actually instead of writing to a file, I can write stuff to a console like this. If I open my window, you can see the recipe was carefully, written to a console. But there is more. Actually, you see where my code is currently at? In Visual Studio, I can drag this cursor and basically go back in time. I'm not really going back in time. I still have this state that drags with me, but I can go back and forth to any line of code that I want just by dragging this cursor, and it will execute the line that I want. So it's an excellent tool to, without changing code, or by adding small changes, you can still remain in the context that you were troubleshooting or inspecting. It's just a great way of trying things out and debugging, troubleshooting. It's awesome. And last thing that I want to show you is intermediate window is the last thing that there is to tell about debugging. You see, we have commented this line out. And what if you wanted to just see, to just think, to just wonder? Okay, I didn't mess things up. You just wonder, what would happen if I save this in a text file? I just want to see in a text file. What happens if I save that to a text file? I can do that. I just saved that to a text file. I didn't execute anything in my code to save it to a text file, but I have another window that takes my application code and allows me to interact with it from the outside, externally, slightly differently. So let's play around with this, right? Let's say I will. So I push the arrow key up to see the options I have. So I'll just write all text to recipe converted 1, write all text to recipe converted 2, write all text to recipe converted 3, write all text to recipe converted 4. So if I open the output directory, I can see 4 recipe files just created with that converted recipe. And I'm just showing very basic stuff right now, what you can do by mixing different things in your application. And it's very powerful. It's basically unlimited, what you can do with your application without even stopping it. So that would be really all that I wanted to show. And that's quite a lot, quite a lot of info for one day. Error handling, files, streams, and debugging. But I hope that was useful. Do you have any more questions before I stop the stream? For consultations, I will not stream them because so far they were not that useful, I think, for the outside people. So I'll keep the consultations, but I will not stream them because they don't add as much value yet. So if you have any questions, please let me know. I'll wait 1 more minute. In the meanwhile, I will push this code. You can see the link in the YouTube video. I will uncomment this. Great. So what did I do? Lesson 3, live coding. Comment all and push. You should see the code now in the link that is in the YouTube video. Can you explain the concept of exception and their handling again in brief? Yes, of course. So exception is basically a synonym to an error in programming. When something is so wrong that it causes an application to crash, you basically have an exception, an exceptional situation from which your program wasn't able to recover from. And not being able to recover is actually not as crazy or as critical as it sounds. It just means that you have an error that you don't handle. And in our case, we have an exception, a custom exception called invalid recipe exception. So if we are trying to process recipe cooking units, and the word before a cooking unit is not a number, for example, if we expect 1, 2, 3, 100, 1000, but it's actually a letter instead, like okay, like boo, like hello. If it's something like that instead, we will throw an exception. So in a program, you can raise your own exceptions using a throw keyword. By calling a throw keyword, you will raise an exception that you specify after the throw keyword. So here we are raising new invalid recipe exception. Actually, exceptions might be rethrown as well. If I just say throw here, it means that I catch and throw the same exception that I threw. Do not do this, because this will drop the stack trace of the exception. Instead, just do this. Anyways, when I have an exception, or rather, when I know that something can throw an exception, I can try and execute that code. So if I put that code in a try block, I can catch some problem that I expect, some error that I expect. And if that problem actually is, here, if this line of code causes this problem, this line of code will execute. So if this try block causes an error, this catch block will catch this error and execute this line of code. Finally, something more rarely used, but it basically means that no matter success or fail, this line will always execute. Otherwise, if this line wasn't here, and I had, let's say, more lines in here, so in case of a fail, line 1 and 2 won't execute. So this is basically an exception. If exception happens, this will not execute, and it immediately moves to this place. And after this try catch finally block, it just goes on with the loop. I hope that answered the question. If it not, please let me know. So I'll try to summarize in short. Exception is an error. You can try to execute code which might raise an exception. And basically, if it does, you can catch exceptions using a catch block. You can catch all exceptions by passing a catch exception here, or you can specify the exception you want to catch by giving a specific type. Is basically all you need to know. Try catch does not raise an exception. Try catch catches an exception. You raise an exception using a throw keyword. And there's nothing more than that. There's no other way of raising an exception. You just raise it using a throw keyword. That's all. This is handling error, and this is the error itself. If this happens, error. And this is the part that you handle the error. So that's the difference. Yeah, you handle using try catch. All right, guys, I will be going. So thank you for your attention, and I'll take it to Discord. I'll stop the stream, but I'll still reply to messages on Discord for as long as there are, and no more than for half an hour more. So see you there, and have fun.